Hello everyone, my name is Andrii Kolhatin, and today I want to tell you about remotely controlled reality in the Robotics Fundamentals course for students of the Information System and Technology specialty. The work was done in cooperation with Oleksandr Kolhatin and Nadia Ponomareva. Robotics is one of the leading fields of modern science and technology. The education in this field is provided from primary school to professional and university study. Of course, each level of education assumes some specific features in the style of teaching and accents in the learning material. We need to form a worldview and understanding of the main principles of robotics in high school and in teacher training educational institution. We need to explain to students the main idea of using sensor and feedback to control a robot or robotic system and give a wide overview of using a robotic system. The main task of professional training and university education in IT specialties is to form uh, competence in constructing robotic system, developing appropriate software for real purpose under real conditions. Such training need a real robotic system to be used in educational process. Of course, technical universities have appropriate equipment in their laboratories. It's not a problem. But let's look at our reality. COVID-19, global quarantine, and Russia invasion in Ukraine. All these events create for us one question. How can we use our equipment in distance learning? So the way that we choose is to create a laboratory with the remote control. Also, we use a virtual laboratory for students' previous training before starting to work with remote controlled robotic system. Let's look what we do. So the purpose of our work is to develop the distance learning technology in the robotics fundamentals course for students and implements it into the educational process. Of course, we are not first who are looking this way. So first of all, we started to research other projects for the distance learning process. Some approaches are based on a virtual environment. But in our opinion, using a virtual environment is good for learning a programming language, but not for a real robotic systems. It can't show the robot's movement in a real environment with different user-unfriendly factors. Other researchers offer to use a complex system where students should create an execution file for robots and the teacher will load this file to the robot. This vision looks better in our opinion, but students can provide their own experiments with robots, and in some cases they can't access low-level programming. To provide the Information System and Technologies educational program, we have formulated the requirements for the laboratory with the remote controlled physical robots as such. Low-level access to component. Students must be able to send any signal to any component of robot. The system should be accessible at any variants of student system customizing and internet provider requirements. And students should be able to design such a robot by themselves with the minimal cost. As component of this system, we use such tools: Gearbot, as virtual environment for modeling, OpenVPN for getting access to laboratory from anywhere without problems, and ESP32 microcontroller for robots main board. Of course, we analyzed Arduino-based robots, but ESP32 can provide much more additional function at equivalent price. At this slide, you can see how we organize the online educational process. During the online practical classes, all students are connected to our university VPN network as a laboratory personal computer. On the other side, the laboratory PC has connection to wireless hub and web camera. We use wireless hub for unplugging robots from data cables and providing more autonomy. More data of this scheme you can find in our paper. For students, this scheme look like that, less complex. After establishing a connection with the university VPN server, a student can get easy access to robots and web camera using his web browser. He can execute his own commands on a robot microcontroller using the REPL environment and MicroPython language. In this time, the student can see the robot's reaction to different commands. Let's speak about student steps in content model mastering. For the success completion of the task, a student should choose robots components, create a model of the robotic system in Gearboard, and test its functionality. After passing all subsystem tests, students convert their algorithm into MicroPython command system and start testing with the remote controlled robot. Real environments allow to detect unforeseen events and requires students to improve the algorithm. You can see an example of a forward-moving function. In this function was created by a student for the task move along the given track. Step by step, students transform his function from primitive of the virtual environment to MicroPython code and to improved code after testing on the real robot. In this example, they found that two electric motors in one model have different characteristics, and creators of the robotic system must take into account such features. The efficiency of suggested educational technology was analyzed on the basis of pedagogical observation, surveys, and students' educational achievement testing. As a result, we can conclude that the course has achieved its purpose. The remote controlled robots is the key element of the courseware in the students' opinion. Students have understood the importance of theoretical basis. Students want to develop their mastering in specific fields, such as computer vision. And after studying the course, students understand the possible using of robotics and automation in real business. We can say that the courseware for the robotic fundamentals course for students of information system and technology specialty has been successfully prepared and introduced. Of course, this system needs some improvements like automatic robots return at home position, different available sets of sensor, and other. The prospects of future work is continuous development of the robotics fundamentals course on the base of student feedback, and creation of elective course in the specific fields of robotics, in particular computer vision. So thank you for your attention. I will be glad to answer your question.